Hey there, and welcome to this exam prep explainer. Today, we're focusing entirely on mastering the 3 decomposition reactions for exams. We're going to explore these crucial ways to break down chemical compounds, diving deep into the data, the exact equations, and the visual observations you need for the most complex ones. Let's get right into it.
So, I want you to just think about this question for a second. What does it actually take to break a chemical bond? Because, it doesn't just happen peacefully while a substance is sitting there in a jar. Compounds are tightly bound together, and they literally must be forced apart. And to achieve that separation, we have to supply a very specific type of energy to overpower those bonds.
And that brings us to our categorical rule of 3. There are basically 3 primary energy sources, or triggers, that we use to force these reactions to happen. Okay, let's dive into this first trigger. To break these bonds, we need energy, starting with one of the absolute most powerful tools in a chemist's arsenal, electricity. This process is called electrolytic decomposition. Take a look at the equation here. We start with 2 molecules of liquid water, right? When a strong electric current passes through that water, it completely forces the H2O to split apart into 2 distinct gases, hydrogen gas and oxygen gas. The electrical energy is literally ripping those water molecules apart. Now, what's really interesting about this slide is that large number 2 right in the middle. Notice how there's a 2 in front of the hydrogen gas product, but not the oxygen? Well, that mathematically represents a physical reality you can actually see during the experiment. Because water is H2O, 2 parts hydrogen to 1 part oxygen, when it decomposes, the hydrogen collects in exactly double the volume of the oxygen. And listen up, because this specific 2-to-1 volume ratio is actually a classic CBSE exam trap. Test writers absolutely love to ask why one test tube fills up with gas twice as fast as the other during the electrolysis of water. But now that you have this physical reality locked in, you're totally prepared for it. It simply comes down to the fact that water inherently has 2 hydrogen atoms for every single oxygen atom.
Let's move on and see how this builds. We've seen electricity in action, but what about the energy shining down on us every single day? That brings us to our next powerful energy trigger, sunlight. This is photolytic decomposition, which is just using light to force a reaction. So, we start with solid silver chloride, which is AgCl. When we expose this compound to plain old sunlight, the light energy forces the silver chloride to separate. The bond breaks, leaving us with solid silver, the Ag, and releasing chlorine gas, the Cl2, right into the air. And this brilliantly illustrates a really striking visible change. See, silver chloride actually starts off as a white powder, but as the sunlight breaks it down and the chlorine gas floats away, it leaves behind pure silver metal, turning the powder gray. That specific color change from white to gray is absolutely a key observation you need to remember for test day. To make that gray color change completely unforgettable, consider this fascinating real-world application. Back before digital cameras were everywhere, photographers used physical film coated with light-sensitive silver compounds, just like this one. If light accidentally hit the film before they were ready, well, the photolytic decomposition would trigger, turning the film gray and completely ruining the picture. This chemical reaction is exactly why old photographic film was always carefully stored and processed in pitch-black dark rooms. Okay, let's pivot for a second and bring this all together with a quick cheat sheet designed to lock these 3 concepts into your memory. So the crucial point here is to link these 3 distinct energy triggers with their scientific names and mental icons, which will pretty much guarantee your success on these questions. First, heat triggers thermal decomposition. Just think of a flame literally burning a compound apart. Second, electricity triggers electrolytic decomposition. Picture a lightning bolt splitting water. And third, light triggers photolytic decomposition. Visualize the sun turning that white silver chloride gray. Heat, electricity, light. Thermal, electrolytic, photolytic. Connect the everyday energy source to its scientific term, and you're golden. You have now officially mastered the 3 decomposition reactions for exams. But as you know, exams absolutely love contrasts. Your next challenge is understanding exactly how these breakdown reactions compare directly to buildup reactions. So, what do you think? Are you ready to tackle the classic combination versus decomposition 3 marker in your next study session?